Hi, Vicky.
Hi, Shane.
Today we're talking about school.
Woo!
So I have a general kind of prompt. What was your favorite? Did you have a favorite subject in school? Favorite year? A favorite teacher? Like, how was your K through 12 educational experience?
It's a very broad question.
I
So,
know.
well, that's a very long time for me. So I started, I've just loved school. I just loved
hmm
school. I still love school. But, when I was younger, I loved all the subjects, all of, math, science, reading, everything. I didn't like anything that I had to do as a group or that I had to do in front of anybody. I didn't like gym
Okay.
or PE. I don't know what anybody calls it nowadays.
Yeah, I don't know either.
Yeah,
We called it gym.
I call it, yeah, gym. But anyway, when I was in grade school, speaking of that, when I was in grade school, I went to a Catholic school and we had like CYO volleyball, and they made us for certain weeks of the year, the whole school, or maybe the whole middle school part of grade school, go down and like play like mixed volleyball in front of each other.
It's like
Like,
a school assembly except
yeah, except
volleyball. Oh
volleyball.
gosh.
And it was like you had to play it with kids from older grades who like actually
What?
cared about it. Yeah, it was terrifying. I hated it. I hated it
This
so
sounds
much. It
terrible.
was horrifying. But then it's funny because then when I got to high school, I still really loved school and all of the subjects, but something changed in me and I became like more outgoing and I became like a terror in gym class, like on the attack. So,
Did you like reap your revenge to
yeah.
those younger kids? You're just like, now I get to do it.
Yeah. It was yeah. Anyway, so things changed a lot for me. Just love school in general
Sure.
though. What about you?
No, that's lovely that you just love school. I don't know. I was ambivalent kind of about school, but there was when I was in high school, there was a moment. So I was always a math and science kid,
Mhm.
and I was always pretty good at both. I guess they're not necessarily disconnected,
Mm.
but we started covering, I forget what grade it was, but we covered Darwin and the Voyage and the Beagle
Oh
and
yeah.
evolution. I never remember enjoying something or being this interested in something ever before that, or maybe ever since,
Wow.
honestly. And it's the reason why when I went to college, my degree is in ecology and evolution. And I went there because like I got that program. I went to that university because it had literally evolution in the name. And it was like that teacher was amazing, that course was amazing, and it's the at least a reason why I am like kind of here today.
Wow.
Yeah, I know, really big deal. But on the opposite end of that, when I was in high school, so the only B I ever got, and I
Wait.
got straight A's. I got straight A's
Okay.
all through high
The
school.
only
This is
B I
not
ever got.
this is not a Shane so smart. It is a my school wasn't very
Oh
difficult.
yeah.
Ask me about college. It was a big reality check. But
Yeah.
the only B I ever got was in English class. And I still remember because my mom worked at the high school. She was our librarian, that she knew this happened. She said, hey, if you go talk to the teacher, like she knows that you're a really good student and just like didn't do a good thing, blah, blah, blah. Maybe if you can go talk to her, she might be able to get a change for you. And I said, no, absolutely not. I hate this class so much. I hate English. I don't know why people do this. I don't know why people like talk about talking. It's like, I forget exactly what the words are, but that was the sentiment. And now I understand, looking back, in this moment in particular, kind of the irony of that.
Yeah. You were like, I'm done with English forever.
I will never talk again.
Yeah, and here you are.
And here we are. Science is fascinating. But don't just take my word for it. Join us as we hear stories from scientists for everyone. I'm Shane Hanlon.
And I'm Vicky Thompson.
And this is Third Pod from the Sun.
So I love reminiscing with you about our youths, but what are we actually talking about today?
Well, today we're talking about education, specifically K through 12 standards and how to make them better.
You know, Shane, I don't think that you would have benefited even if there were better standards when we were kids.
Oh my gosh, Vicky, coming out hot this morning. Oh, that is just, I very much appreciate that. So I do have a PhD, you might know. know it from our discussions. But anyways, we're getting off track as normal. I'm going to bring in producer Jace Steiner, who's actually our former intern and the artist behind many of our lovely episode cover art, to tell us more. Hi, Jace.
Hi, Shane. I've been dying to say that as a guest on the show. I mean, not that I've never said hi to you before.
I bet you've heard a lot of hi Shanes from working on the series internally.
Like the sounds of the city, I don't even really notice it at this point.
So speaking of sounds of the city, why don't you give our audience a little visual, or I guess audio interpretation of a visual of your recording setup at this moment?
Well, I live in New York City, and I also live right next to an above-ground train, and right across from construction. And so my apartment is very noisy. The walls are very thin, but I do have a closet. It's very, very small. It's about shoulder width, and it has a built-in shoe rack. So I'm sitting on the shoe rack, and the mic and the laptop are on a shoebox, and I've got my clothes all around me to help dampen the sound. It's a good time.
Oh, I feel like half of podcasting is just dealing with the fact that sound exists. And actually, as I say that, I think that's the entire point of podcast, is that sound exists.
Yeah, so speaking of that...
Right, so today we have an interview with Michael Wysession, a professor of Earth and Space Science and a decades-long advocate and contributor to improved K-12 science curriculum standards. He's also the editor-in-chief of Perspectives of Earth and Space Scientists, an AGU journal that's basically the spine of this miniseries.
Spine?
Maybe that's not the best analogy? Like, thread of the series. Like, the underlying thread that connects everything. The glue?
I kind of like spine. So then each episode is like a nerve or an appendage that makes up the whole body. So this one could be the head.
Yeah, like Frankenstein's monster.
Or a big robot, like Megazord from the Power Rangers. Go Power Rangers.
Oh, I was hoping that would happen. Oh, man. I got to say, it's a little strange for me to be the one who's having to bring us back on topic. So anyways, back to you, Jace.
Yeah, I had a great time chatting with Michael. He's an incredible speaker. I was doing the whole spiel of, once I hit record, you can re-say anything you need because this isn't going to be live, blah, blah, blah. And he says, oh yeah, I've done 100+ video lectures with multiple cameras pointed at me.
Oh, he knows what's up then, huh?
Oh yeah, for sure. Super well media trained. But also, a very accomplished educator and scientist with many years of experience.
Great. Let's hear it.
My name is Michael Wysession. I'm a professor of geophysics in the Department of Earth and Planetary Sciences at Washington University in St. Louis. I'm also the executive director of the Center for Teaching and Learning at the university, where I'm responsible for the pedagogical training for faculty on campus. Right out of college, I went to school in Rhode Island and went straight to New York City to teach high school math and physics, by far the most exhausting and in many ways the most rewarding job I ever had. But I went to graduate school after that in seismology. I used seismic waves from large earthquakes as a means of making 3D pictures of Earth's interior, as a way to understand plate tectonics and why volcanoes erupt where they do, and just the overall interior structure and pattern of how the Earth works. So I did that for 5 years in Chicago at Northwestern University. And then directly from there, I came to St. Louis to Washington University and was fully immersed in my research program and got some good breaks and a lot of good luck and got awarded a presidential faculty fellowship at the White House from Bill Clinton. But I found that the educational side kept pulling me back towards it. I felt a little bit like swimming upstream. And increasingly, even though my focus was the geophysical research, I began to be more involved with science literacy and geoscience education at a national and an international level. And that just has sort of increased to the point where it's probably more of my overall time now than my seismology research.
I guess that leads into my next question, right, is you recently published the article, The Challenge of Getting Earth and Space Science into U.S. High Schools, with the journal that you lead, Perspectives of Earth and Space Scientists. Can you tell me more about the goal of the journal and what inspired you to write this piece in particular?
I've been an editor now for 5 journals with the AGU. I just love the process of publishing and journalism in general, as well as journals. I actually, in high school, I thought I was going to be a science journalist. My childhood idol was Walter Sullivan, who was the first science journalist at the New York Times, created the Tuesday science section. But I've always been really interested in writing the written word. And currently, I'm editor-in-chief of the journal Perspectives. And this is a little different than most other science journals, where usually we discourage an author's personal voice in the articles that they write. Here, it's a critical part of it. We want the scientists to tell their stories along with providing a message, a perspective on a particular science topic or field. And this is just a wonderful means of conveying information. We've evolved to be able to learn this way very effectively. And this aspect of storytelling is critical to this journal, Perspectives, where, we're interested in the science, in sort of providing lessons for the geophysicists of the future, the earth and space scientists of future generations, by learning how fields started, how they evolved, but also the careers of the individuals, their personal struggles, their triumphs and failures. Because when you learn the scientific content through the framework of someone's story, that personalization becomes very engaging and powerful, and just a tremendous way to learn. Now, in parallel to that, the whole way we have now learned to teach science K through 12 is also through this storytelling. There's a form of learning science called phenomenon-based learning. That now it has really taken over our country in a good way in terms of how we teach children science. This phenomenon-based learning started in Finland and then spread throughout Scandinavia, and now has sort of taken over the world. But the basic idea is, if you want students to learn something, you have to give them some connection to it. So you introduce some relevant, intriguing, interesting phenomenon, and you have them ask questions about it. So it might be like, how old is your body? And they might say, well, yeah, I'm 15 years old. And I say, no, let's go back to the atoms of your body. Like, how old are those atoms? And then you encourage the students to start asking questions. And their questions then drive this cycle of inquiry where they dig deeper and deeper. They have to learn about the evolution of Earth and the Earth rock cycle and radiometric dating. And you get back to the supernovas that created all the larger atoms in our body 4.6 billion years ago. And you get back to even the Big Bang 13.7 billion years ago, which made all the hydrogen atoms, which is half of our body. So they end up, well, first of all, they never get to say, why are we learning this? Because they're always answering their own questions. They know why they're learning it. But they end up having all of the content directly connected to this phenomenon that they're exploring. And so, they come to the realization that when they look at the mirror, half their body is 13.7 billion years old. The other half of their body is 4.6 billion years old. Yeah, they don't look so bad for something that's, many billions of years old. And this way of learning, this sort of phenomenon, is now a huge part of our educational effort in the country. And this is developing these storylines around which the science content can be taught. And, I had the true honor of being in charge of Earth and space science for what is now the science standards for 45 states and DC in America, through first at the National Academy of Science, the framework for K-12 science education, which I was the design team leader for Earth and Space Science, and then the actual writing of the next generation science standards, where I also ended up chairing the Earth and Space Science team. So, I've played this sort of direct role in getting these storylines about geoscience, Earth and space science into the K-12 world. And that's really been a sort of huge part of my career over the past 15 years. And so I talk about this struggle of, in this article that you mentioned, of getting Earth and space science, in particular, issues such as climate and climate change and human impacts and environmental impacts and natural hazards and natural resources into a high school curriculum where really it hasn't been for most of the past 200 years of our country's history. So I think it's no surprise to anyone who's been looking at a newspaper for the last 10 years that there are a lot of serious issues facing humanity. Some of them are political, some of them are cultural. A lot of them have to do with the earth. And so, I'm in St. Louis, literally blocks away from me. Cars were floating down the street a week and a half ago. Our flooding was so severe here in town. We had this record-breaking 12 inches of rain in less than a day. We never had come close to this before. At the same time, there are severe droughts and forest fires hitting, other parts of the country and the world. Climate change is a natural part of how the earth operates. You can go back through time and you find climate changing steadily, continually. Rarely has it changed so rapidly, though. Our efforts have been to get climate into a rigorous curriculum that is heavy in the physics and the chemistry and the mathematics. The next generation science standards is also truly a STEM program in which the science isn't just taught from a sort of list of facts, which both is not a great way to learn, but also in the case of climate science can be a little depressing. Kind of leads, it sort of reads like a long list of horrible ills that our children will face in the future. But it incorporates aspects of engineering and technology that have this sort of problem-solving aspect to them. Our programs that are now coming into high school dealing with climate and climate change are done from a point of view of, here's a challenge. How would you develop a solution to this? Or, here's a potential problem. How do you figure out the costs and benefits of different solutions and evaluate between them? And that presentation of material in a way that empowers the students as both being active in making decisions and finding solutions gives them a sense of hope. And really, hope is the most critical factor in a science education that deals with issues such as climate change.
Okay, so thinking about all of this, I don't think that I learned anything about climate science when I was in grade school. Did you?
No, I don't think so either. I didn't. I was very biology heavy, and so I work at AGU now, and I didn't even take a geology course ever, frankly. Even though climate science is this big umbrella thing, no, I can't remember ever really doing anything climate related. What about you, Jace?
I mean, I graduated high school in 2018, but I only remember brief lessons in maybe 6th grade and middle school, maybe high school. But truly, most of the knowledge I have on climate change comes from the internet and college and just talking to other people, which is kind of wild considering that many climate activists today aren't in high school, I feel like.
Wait, did you say you graduated high school in 2018?
Vicky, we're old. We're not talking about it.
It's okay, guys. I just benefit from learning more than you guys.
Yeah. That's true. It's true.
Yeah, seriously. Oh man. Well, I mean, with that though, honestly, there should be some sort of a curriculum for adults, probably especially lawmakers.
Right, because in the end, the people who can actually make decisions about how our country responds to climate change are adults. And many of today's adults did not have a chance.
So anyone who lives in the US knows we don't so much as live in a country as in a loose confederation of states. States don't like to be told by the federal government how they vote, what guns they can carry, what they can smoke, who they can marry, and sure as heck, how to teach their kids. To the point where this is actually codified in the 1965 Primary and Secondary Education Act. It was basically a deal that Congress made with Lyndon Johnson. President Johnson got the funds he wanted for his war on poverty, and states got a written codification of states' rights concerning education. So it is illegal in the United States to have a national science curriculum. The federal government cannot tell states what to teach. So that makes basically what that means is you have 50 states all reinventing the wheel simultaneously, often the same way, but often with slight differences and nuances. The fact that 20 states and DC actually adopted the recommendations of the Next Generation Science Standards verbatim is stunning. But it shows something. Oh, and that 45 other states also adapted these standards to a very high degree. Often the changes are very minimal. And this is a real tribute to the fact that it is a STEM program. And honestly, there was a lot of pressure from corporations and businesses saying, look, let's put politics aside. If we don't have a science, technology, educated population, we're not going to be able to compete on a global market. And so we need students who understand how to engineer, how to program, how fundamental science operates. And that, because of that, I think we had almost total buy-in across the country. Now, that said, how things roll out in each state, how they implement them, the programs they use, the curricula they develop, the textbooks they purchase will vary dramatically from state to state based on the particular histories and biases and leanings of their state legislatures.
So then, in writing these curriculums for K through 12, how do you structure it, and how is it integrated into the schools?
When we started the work at the National Academy, coming up with this sort of framework for K-12 science education, we were motivated by sort of two large ideas. One was to reduce the total volume of factoids that we were going to ask both teachers to teach and students to learn, and really focus on the essential big ideas. The other issue that we faced was learning progressions. How do you present this to students in a scaffolded way that they are capable of learning it? So, for instance, we often talk about things like seasons, and we want to talk about the ice ages in middle school. Okay, let's start with this. We have all the teaching force here. Let's take the Earth and space and make them the phenomena. Let's build our storylines around these Earth and space science phenomena for our biology and our chemistry and our physics courses. So in chemistry, they still learn about chemical reactions, but they use the combustion of fossil fuels as the type example, which then creates the carbon dioxide, which goes into the atmosphere, which causes climate change, which also then, because of equilibrium forces, gets increased carbon dioxide in the ocean, which leads to ocean acidification and damage to the coral reefs. So the phenomena are things like, why are there all these floods? Why are there these forest fires? Why are the coral reefs being damaged? And as students ask questions through this sort of spiraling of investigation, it brings them, back to the chemical reaction, the burning of fossil fuels as the cause of this. But in the process, they learn the earth systems, the climate systems, the impacts on the biosphere and the ocean.
So what sorts of materials and projects have you created to address this?
Some of my colleagues said, well, let's make a textbook that fits this. And our, it's largely labs and demos and student debates and questions, but there is also a student handbook. Again, it's not at all like the old textbook, of the old days. That's done and gone. But the student handbook has 150 pages about climate and climate science and its impacts. And the impacts of climate change on the biosphere and the ocean and the atmosphere and humans. And the advantage of having it in a high school chemistry class is we can get into details of the science. You can talk about carbon-13 isotopes and how that shows that the carbon in the atmosphere is not from volcanoes, but is actually from the burning of fossil fuels. And you can get into the molecular oscillations of carbon and ozone and oxygen gas molecules as part of the greenhouse effect. And you can have students understand why certain wavelengths of radiation are absorbed and not others, and therefore how to develop potential solutions for mitigating an increased greenhouse effect. And the earth and space science makes just such wonderful storylines because you have this cool things like volcanoes erupting and earthquakes and droughts and climate change and their effects on history. You can go back and trace the rise and falls of civilizations, and they're so tied into the geology and the climate change and where cities developed on the mouths of rivers and what happened to them when the sea level went up. And it adds this relevance to the lives and histories of the students themselves, that it just becomes a very sort of sensible way to organize the science and have students learn it.
Okay, you mentioned moving away from textbooks. Say you're talking with a colleague or another scientist about writing new educational projects. What's your pitch for them?
So there was something that the chair of our NGSS writing team, Stephen Pruitt, who is just a sort of brilliant at understanding educational systems from sort of the political level on down. And he would give this story, and he would say, all right, suppose it was your job to teach kids how to play softball or baseball. What would you do? Okay, well, one way would be you give them a textbook, you sit them down, they learn the rules of the game, the dimensions of the field, the size of the bat and ball. You have them memorize all this information, and then occasionally you give them a multiple choice test. The students who do well in the multiple choice test, you put into an honors class. And there they learn the statistics of players. They learn the more esoteric rules of the game, like the infield fly rule, or why it is that the ball is fair when it hits the foul pole. At the end of a year, how well are they going to play softball or baseball? And more importantly, are they going to care? No. The way kids learn to play softball and baseball is you give them a glove and a ball and you kick them outside and you don't let them come in until their knees are dirty. And what happens is they learn to love the game first. And guess what? Then they do learn the rules of the game. They learn the infield fly rule. They learn the statistics of their player, of their favorite players. And guess what? They still go to ball games 40 years after they are not able to play anymore. It's not because they learned it in a class and it was interesting. It was because they did it and they had fun with it. So why is it that we teach science in that same ineffective way? Why have we sat students in a classroom with a dusty old textbook that's 10 years out of date? And frankly, textbooks are out of date the moment you publish them anyway, because the science is always changing. And why have we forced them to learn and memorize all these facts about science and spit them back on multiple choice tests? And then why are we surprised when they are bored and turned off with it by the time they get to high school? What the NGSS does, and all these new educational programs that get rid of the textbook, of which I am so happy our high school chemistry and physics programs have done, is we let students play with the science. We let them do the science. We let them experiment with it.
So, with your research and education experience, did you ever feel unsure about where your career was heading, torn between the two, or do you feel you've integrated them together in some way?
It is, it's very hard to be good at one thing. It's exponentially harder to be good at more than one thing. I look back at history and people who are polymaths, who have, mastered writing and art and music, and it is truly remarkable. And there are some people currently who can do this, who have been awarded for their writing and their acting and their music, and it's awesome. In my own career, I have tried to walk this line by being as good of a seismologist as I can and as good of a science educator as I can. And it's hard because I basically work two jobs. Honestly, through much of my career, I haven't gotten a lot of sleep. It's, impacted my leisure time, my relationships. But I find for me, the level of expertise I got in my science was, putting out networks of seismometers across the island of Madagascar to make 3D pictures to understand why there are volcanoes erupting in the middle of the island. These sorts of projects were absolutely critical in giving me the ability to go into the science literacy world, or the science curriculum world, or the science education world, and negotiate with publishers, with talking with politicians. If I didn't have that, both understanding and honestly credibility, to say you were awarded a presidential faculty fellowship at the White House gives you a certain credibility that opens doors for you. Maybe it shouldn't, but it does. At the same time, my understanding of the importance of communicating the science to the public for the future of our world's sake has given me a motivation that has kept me up at night finishing projects and doing my science. I feel a certain I feel a connection with the world that comes from my science. And through that, I feel a responsibility to it.
Before you go, I wanted to ask, do you have any advice for young people wanting to get into science or into a science career, be it science education or just science itself? What words of advice would you leave for a young person right now?
My advice would be, whenever possible, put down the books and get outside. I think that the world has so much to teach us, and we get caught up in the information, the facts. And it sort of reminds me of Lao Tzu's, the Tao, where there is a saying in Taoism, the Tao that is written is not the real Tao. The true understanding of science doesn't come through reading about it in a book. It comes through either doing the science or exploring it. And honestly, some of our best experts going back centuries understood this. If you go back to that powerful 1893 Committee of 10 report that shaped our science education for the next 130 years, one of their recommendations was that students in school spend one whole day every week just outdoors, just playing with the mud and looking at the organisms and the rocks and getting a sense of how the world operates in nature. Honestly, for me, I'm very grateful to have had the opportunity to spend a lot of time where my mom grew up in northern New Hampshire, hiking in the mountains. I know not everyone has the opportunity to hike in mountains like the White Mountains of New Hampshire, but there are marvels outdoors anywhere. Honestly, the parks in New York City were also spectacular, and so just get outdoors. The facts, the information will come. Develop that connection with the world first. The other thing that I would say is have some faith in how clever we are as a species. Don't despair. We've gotten ourselves into quite a few jams right now. And, things are not looking good with the changes in climate, the rise in sea level, and there's a long list of things. My message would be is have some faith that we're clever and have fun with the science, get excited about it. There are so many employment opportunities now, whether it's in medicine or business or law or engineering, that all involve aspects of earth and climate, that whatever it is you're good at and whatever it is you like to do, you will be able to find ways that you can help your planet, that you can sort of carry out your responsibility for helping to make the world a better place than what you found. Countries beginning to understand the power that humans have. I know it's a little corny to quote Spider-Man, but with great power comes great responsibility. Actually, people have been saying this for millennia, but I like the Spider-Man version of it. And we are powerful, but as a result, we can also change things for the better.
I think that's a good note to end on. Learning about climate change can be scary a lot of times, but binding a hopeful message to K-12 science can make me feel more hopeful about our future. Big thanks again to Michael Wysession for sitting with us.
All right, folks, and that's all from Third Pod from the Sun. This episode was produced by Jace Steiner with audio engineering from Collin Warren.
We'd love to hear your thoughts. Please rate and review the podcast. You can find new episodes in your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next week. Perfect. All right, then we'll go to that first transition.
Oh, that almost was Indiana Jones. Ba-ba-da-ba.
That was me trying to scroll because suddenly it's frozen for me. Oh, there we go.
Ba-ba-da-ba. There's a weird amount of singing in this episode.
I love it. Have I had the chance to say that I played Jesus in Godspell yet on the podcast? When I was in high school.
No.